about how do we prepare when we plan, or what we have to do to experience least amount of loss or least amount of dealings with loss of property, loss of functionality of the facility, and things along those lines. One thing to consider is that there's two types of disasters, and that was basically stated before. You have the natural disasters, which include earthquakes, landslides, mudslides, floods, heavy rains, flash flooding, hurricanes, tropical storms, winds, rains, lightning, hail, freezing weather, storms and typhoons, tsunamis, tornadoes, volcanoes, wildfires, and heat and drought. And then you have the human-caused disasters, which are power outages, fires, wars, terrorist attacks, civil unrest, engineering dam failures, mining disasters, agricultural scenarios, air pollution, water pollution, hazmat spills, environmental and ecological issues, hydraulic and groundwater contamination, industrial, chemical, biological, and nuclear accidents. So some of those things we could control, and some of them we have to plan for. And a lot of them we could plan for in the beginning, or the other thing that we have to do after we plan for it, we have to maintain our facilities to make it functional, so when a disaster occurs, we're basically protected. And for a simple scenario, like if you're building a warehouse or you're building an office building and it's already, you're moved in and you're living there and everything is all nice and fine, you should ask your professional, your professional designer or your contractor, what are the warranties on materials that you have there? How often do you have to caulk the windows? How often do you have to replace the expansion joints in your structure? They basically last somewhere between 3 to 6 or 7 years. And not too many people know about that. So now you have these issues, you have water infiltration, you have wind, and all of a sudden your structure that was designed for 100 or 200 or 120 mile winds, all of a sudden is exposed to the elements, and that structure is deteriorating. So therefore, your wall may come down, your structure may get affected, you may get water inside of the building, so you have more damage that you could have controlled if you planned some type of a maintenance approach on it. Same thing happens with roofs. You have roof drains that get clogged up, then you have rainfall that comes in, you have a great deal of water on the roof, then that roof freezes because you're going into a cool cycle, then snow comes in, then you have rain again. All of a sudden you have a roof collapse. But that roof collapse wasn't really caused by nature, it was caused by negligence of not keeping up with what's going on. As codes go, if you look at the history of disasters, codes change with disasters. If you look at history, going back to Roman 64 AD, London 1666 and 1940, Moscow 1812, Washington DC 1814, New York City 1835, Chicago 1871, Seattle 1889, Toronto 1904, Baltimore 1904, and San Francisco earthquake of 1906. All those things were positive on protecting ourselves. And basically the codes changed, and we started designing for earthquakes, for hurricanes, for tornadoes. And there's many testing labs connected with different universities on how to work with existing facilities and how to design future facilities to protect for that. Living in New Jersey and New York metropolitan area, not too many people know that we're on a earthquake fault line, but not too many buildings are designed for that. The code has changed approximately 10 years ago to take care of that. And a simple scenario of adding a couple of wires or reinforcing the structure or making the structure a little bit tensile solves those problems. A good example is this room itself. How do you design for an earthquake in this room? It's very simple. You basically reinforce the ceiling and the lights and the HVAC ductwork in this room. So it's not just wires that are holding the ceiling. It's individual scenarios that happen here. In my handout, I basically provided you with information on emergency protection for families, individuals, households, and pets, terrorist and biotechnical information. It's on the second page, so you could go through it. I'm not going to go through all of that, but it gives you a guideline of all the information that's out there that you could look up and prepare yourself for. On the next page, it gives you a checklist on damages that a structure could happen, what the description of it is. This checklist is provided by the American Institute of Architects for Disaster Assistance Program. They have a whole packet on analyzing buildings and structures after a disaster happens. So when you have a meeting with a professional or you have a meeting with your insurance agent, you could follow what's damaged, how you could claim what's insured, what's not insured, and how you could better serve and stand up for your rights as it relates to that. On the next page, and that's actually pretty important, is after the disaster happens, there's 3 different classifications. One is you only have 10% evaluate, you have only 10% damage on it, which is a green sticker, and it gives you a checklist of items that are 10% damaged. Then you have restricted, which is a yellow sticker, which basically talks about what would be damaged to get that classification, and that varies from 20 to 70% damage of an existing structure. And the last one, which is an unsafe structure, which is 80 to 100% damage, and that gives you a bottom line on what that is. The other 2 sheets are basically off of New Jersey website on code enforcement, and it tells you what are the design criteria for structures in the state of New Jersey. If you're living on the coastal area, the structure is supposed to be designed for 120 mile winds. A little bit more inland, it's 110. In the area that we're here in, it's about 100 to 90 mile winds. So what does that mean? It means that the walls could stand up for that strength of the wind. Also, you're designing the uplift on the roofs itself, but it also takes into account the warranty of your roofs. A standard warranty for a flat roof is somewhere between 15 and 30 years. Now we're in an age that a lot of landowners and tenants are going into a partnership with public service and installing solar energy. Solar energy is a plus in 2 ways. The first scenario is that it diffuses the demand of power for a given scenario, but it also increases your warranty on your roof because you're not exposing your roof to your elements. But a solar installer will not put in an installation unless the warranty of the roof is probably over 20 to 25 years. An average solar system installation is guaranteed for 20 years. So taking that into account, you're extending your life expectancy, your warranty on the roof. But the other thing that you have to take into account is how is that solar installation done? And what are the parameters of it? One thing that you have to take a look at is if it's on an angle, you're going to have wind load issues, you have snow issues on the roof, so the roof has to be designed for that. The other thing is if it's a flat installation, what happens if you have snowfall and you don't have any exposure on it? And then what happens if you have a lot of hot weather? How efficient are those panels? So all those taken into account deviate from your operation. The other thing that the public utilities will force you to do is, you want to have redundancy, but solar may not be your redundancy scenario, because if you have outages across, you cannot produce electricity and throw it back into the grid. So you have to have some type of a battery system if you elect to do so, or some type of other standards that you have to follow that the utility company will agree with you on. The other approach is on the roof itself to have a green roof. What does that mean? It means basically putting some dirt on the roof and having a plant area to give you more of an insulating factor. And the plus in that is you're lowering your exposure to the elements, you're strengthening your structure, and you're also managing the water runoff. We talked about briefly about water management and the utility and things along those lines. There's a lot of products out there that we could deal with that manages water on our own site. Green roofs is one because you're retaining some of it. Another way of doing it is having your parking lots and with porous paving. So the water basically goes through your paving system. It goes in the ground, so you don't have to dump it to the county. So the county has to, create more water treatment plants. You don't have to worry about the runoff going to the Passaic River and flooding Jim's house out and things along those lines. So all those things considered, we have to be all advocates. Us as professionals, us as building owners and occupants, and the utility company. We all have to work together to minimize our disasters, because some of these disasters are nature caused and some of the disasters are caused by us by not managing our resources and not managing our sites correctly. So they may not impact you directly, but your impact or your mismanagement may impact your neighbor or your community. So that's something that you need to consider. The other thing that you need to do is this. When you have a disaster, you have to have a redundancy. And redundancy is not just as a generating system or record management or everything else that you need to do. First of all, you have to have a plan of how and where and what is your travel distance of going from your house to your office. If, let's say, the roads are flooded, how do you communicate with your staff? Who are the key individuals? Where is the most important place to manage your records? You should always have two sites on keeping records. One is, if it's electric records, you should have an off-site scenario or create a hot site scenario that you could plug yourself in if your facility is down. The other thing is to have a operating manual for your facility. And in that operating manual, you should have a set of drawings for your building. You should also have all your insurance policies, key contact information for professionals that are involved in your building, key contractors that maintain your facility, and have maintenance agreements with them. So they will come in and walk the premises with you, and they will inspect your premises. So when there is a disaster, you minimize your loss. And minimizing your loss meaning managing your property correctly. And then all those records have to be stored off-site somewhere in a different geographic location or somewhere else. So when your facility is damaged or destroyed, or those records that are on site are destroyed, you could have a set of records to look at, to identify what you need to do, and it solves a lot of issues for people. One thing to consider, the people that you hire, you have to trust them and you have to analyze how they're going to respond in your emergency. Are you a loyal customer to them? Or are you basically just going to call them in case of emergency? If you have a relationship with them, then they're going to respond to you. The other thing that you have to consider is where are they're located. Because if, let's say, their business is located in a floodplain and there is a flood scenario and you have another emergency, which is a power scenario, and they're an electrical company or something like that, will they come and address your emergency if they have an emergency of their own? And how high or how low you are on their pecking order. So relationships and working together is the best approach you can